like to use this discussion after we go through the discussion of ISAT to go back a step out to think about our observing system, our observing co-leads that are part of environmental intelligence. And we have a joint meeting with them planned for next month. So kind of bridging that next step to the next meeting. ISAT-2 is an observing asset, and we want to try to bring it back to the high level and how IARPIC is helping us with observing asset coordination and research. So with that, if we're good with this agenda, I'm going to start by, I have some notes that I'm going to read to my, just share with myself so I stay on topic. But feel free to interject at any point if you have questions. Now, for those of you who might not be familiar with this, there is a federal data strategy that I've been talking about on this team for the past 6 months. And it was first released was published in June 6, 2019. Federal data strategy is being coordinated across the government. So it's not for any particular department or agency. It's not for IARPIC research. It's not for Arctic stuff. It's very broad. And however, I brought it up because I think in the earth science community and maybe to a lesser extent in the Arctic research community, there is not enough coordination at a strategic level to understand our data systems and how they're interdependent, and in order to enable large-scale science, data-driven science, and to answer the questions that society really needs us to do right now. So that's not to say people haven't been trying to do things like mapping specific observing assets to societal objectives. That does occur, and we show by doing that through this mapping activity that these are going to contribute, or in theory could contribute to meeting our society's needs. But what that federal data strategy actually says is we have to go in and identify these assets, these data assets, and build plans for evaluating them to see how they are being used currently to address agency mission activities. So how they've been justified historically and why those data assets are being funded and are such a strong investment for the government and should be moving forward. There is a little bit of this, the result of that might be, oh, we're going to reprioritize because maybe we're investing in the wrong things. So that's kind of the management side of this, is trying to improve the efficiency of our data investments. And there's a couple new things that have occurred, say in the past 7 years. And one is the open data policy, which was an executive order in 2013. And that changed things to some extent for a lot of federal agencies, because we were now required to put data out in a public space for others to use. So it was no longer just for our own agency's needs, because in theory, we could collect this data, conduct this research, and achieve the purpose what the data was collected for without sharing with the public. So by making the data open and available, I think that does mark kind of like a change in the way agencies are conducting science. And that's been happening, that's been in the process of being implemented still, but for the past 7 years. So it's really not new. the progress that has occurred since 2013 is that the earth science community, through various initiatives and organizations like AGU and others, have promoted this thing called the fair data principles. And I don't know if you guys have heard much about those, but what this represents is that earth science community and the broader data management community coalescing around some expectations and practices for open data. The FAIR stands for findable, accessible, interoperable, and reusable. So those are kind of good catchphrases. The principles that are nested underneath those, and in a variety of ways, we're trying to implement this across various earth science domains. The thing that has changed more recently with, there was a new law called the Open and Necessary, it's basically the Open Government Data Act. That's the short name for it. Open and Necessary Data. I don't remember what it stands for, but the open is actually, the word open is actually an acronym. And what's really new about this, and what we've been digesting for the past year since it came out in January of 2019, is there's an engagement requirement, engagement within the agency to address that efficiency question I talked about. So we're making sure we're investing in these data assets so they achieve their ultimate purpose or their primary purpose. But also, when we disseminate data for any reasons, say in the regulatory context, we disseminate data for the purpose of decision making. And whenever we do that, we have to provide information to the public on, well, not only make it open and accessible, but on how we use that data. So we're making it very transparent how that's part of the decision process. We have to get into this engagement to prioritize which data assets need to be made public and machine readable, because we can't do everything at once. So there's an engagement aspect for prioritization. And then finally, there's an opportunity through technology transfer to do competitions or other collaborative projects with the community to add value to these data assets. So we may have thought about a data asset in our context, in our agency, but when someone from the outside looks at it, they say, oh, we can also use that data to do this other analysis, and that's adding value that we didn't anticipate when we created it. So, but I think the cumulative result of this, and I'm sorry, and this might not get at the, to the level of the graduate researcher who's about to start collecting data and wants to know how they can be better, do it in a better way. But we're really talking about societal change. And I think what we're moving towards, and this isn't written anywhere, but it was kind of hatched when Mike and I were talking about this, is what happens when you make these data open and you layer on top of that the engagement requirement? What's actually going to change from the result of these new data laws and executive orders? And it could be that now you get into a scenario where there's more co-production of knowledge occurring, and that's fundamentally informing policies of the government and how we carry out our activities. So just to capture that theme, and I want to bring in Mike at some point with the thinking, we want to solidify this as a recurring theme. And in the past, I've talked about the coming up with a strategy for the community and how we can actually tier off this federal data strategy using some sort of roadmap for IARPIC and data. And I think one way to develop this roadmap is to come up with specific themes. And what this will do, and if we can map the specific themes back to the federal data strategy, and also show how they connect and help us deliver on the IARPIC performance elements. And I won't go into what those are, but this is basically, winnowing from very broad federal mandates down to what we're doing for Arctic data. I think, that process of coming up with these themes and then organizing these meetings around them, that's a way to help us stay on topic, achieve our results. And Mike has ideas, and I'm still, I'm totally on board with his approach of structuring these meetings and engagement across the federal agencies and with the research community around specific themes or the performance elements themselves to help us kind of stay on topic and organized. And at the end of the year, we'll be able to better report out to the federal leads for IARPIC what we did this year. So I'm going to pause right there, but I'll get to what this new theme is. I want to let Mike jump in there if he has something to say.
Yeah, thanks, John. I think this is terrific framing, not only for this call, but for many future meetings to come around the topic of interagency interaction for enhancing Arctic data. Now, 2 points that I want to get to the ISAT-2 team. And I'm going to kind of plant 2 seeds that I hope to kind of return to at the end when we have discussion. First, for those that are not familiar, I know many on this call are, IARPIC has called performance elements, and we have specific performance elements that the Arctic data sub-team tends to gravitate towards to support. We end up reporting progress towards these performance elements annually. So if you're not familiar, please take a look at the website, look at the Arctic data team, and take a look at those PEs. I want to return to that at the end for discussion. And then one more point, and then we'll get to it, co-production. I want to kind of weave that into the discussion later on. Just generally thinking, not necessarily co-production of knowledge, but data information, user-producer interactions to enhance usability of data information and potentially create new knowledge. So with that, just want to return to those ideas, but for the sake of time, I'd like to get to ISAT-2. Now, Jonathan, did we have a time for the presentation, 20 minutes or so? Did we confirm that with the presenters?
Well, I think they could take longer. So we'll give them 20 minutes and then come back to the broad group discussion.
Well, I have a sense that ISAT-2 is going to be part of this conversation going forward, so we'll leave it to them to let us know how much time they want, but I would like to have good time for discussion towards the end. So ISAT-2, did you have a time in terms of length of presentation so we can plan our discussion? If you're talking, you're on mute.
So there you go.
Oh, how about now?
Yes, we can.
Oh, now we can hear you. So
Now you got it.
you're
okay. Yeah, we should be kind of 15 minutes. We'll try to keep it to that. Nathan has the slides, and if you can transfer over to him, we should be able to do that.
Okay. Yeah. Great. Thank you. Is this working?
Yeah. Yeah, I can see it, Nathan.
Okay. Let me. Is it full screen?
It isn't. This is what I see.
Okay. Let me.
So while Nathan's getting it on full screen, I'll just introduce myself. And I'm Tom Newman. I'm the project scientist for the ISAT-2 mission. And Nathan will be doing the slides today and talking to him. Oh, that looks good, Nathan. And Nathan, of course, is the deputy project scientist on ISAT-2.
All right. Yeah, thanks for inviting us to the meeting. So yeah, we're just going to talk through some of the data strategy that we've had for ISAT-2. It's evolved through the years, but now we're kind of in production mode, so and looking to expand. So yeah, hitting on some of the topics that were mentioned earlier about getting data out to the public. Just a brief mission overview. What is ISAT-2? I don't know if everyone is familiar with it. It's a laser altimeter, so LiDAR. The basic product is it measures the round trip travel time of laser light to get height. It's the successor to the ISAT mission, another laser altimeter that was up from 2003 to 2009. It's a single instrument satellite, and so we're, it's not an Aqua or something that's getting many different data products and looking to merge these together. We're a LiDAR, we're getting heights, but we do look at getting different height products for different regions and looking at different geophysical products. We launched successfully on September 15th, 2018, so not too long ago, but enough that we're able to now in the getting through the calibration phase, our commissioning phase, and getting data products out. So, and then one more brief overview. Again, what is ISAT-2? So it's not just a single laser pulse or a laser beam. It's split into 6 different beams, and we're tracking individual photons. And so the data itself, I'll show a bit later, is looking at these single photon heights and then looking at aggregating those into, again, different geophysical products depending on the surface that we're over. So the data size, the footprint size is about 15 meters. We're taking measurements about every 70 centimeters on the ground, and the beams are split as shown here. We have what are called our strong beams, or the beam pairs are, so we have a strong and a weak beam. Those are separated by 90 meters on the ground, and then the strong beams are separated by about 3 kilometers.
Nathan, I'm not sure what happened, but we lost your slides.
Yeah. Might need to share screen again.
Oop, there they're back.
Is that working?
Yeah.
Okay.
And just whatever you did to make them full screen.
All right.
There we go. So we're
Okay.
Yeah.
So this is just a picture from our first light. This is what the data look like. This is over Antarctica. Each of those dots is a photon, and the y-axis is height. And so this is just tracking a fairly smooth section of Antarctica. The solid line is, if you aggregate the photons, that would give you the height of the surface there in Antarctica. And all those other dots, there's a lot of background from the atmosphere. But that is essentially, in a nutshell, what the data look like. In terms of data flow distribution, this chart really just describes what it is. So what I showed before is what's called ATLO3. Those are the geolocated photons. Those give a height estimate for each photon. On a lower level, we have data that, really what we're measuring is time of flight of a laser pulse. And so those are the precursor data products, ATLO1 and 2. We have to do a lot of work to get our pointing and our orbit down, but most users would probably be interested in the ATLO3 geolocated data products. That forms sort of the core basis for what people would want to work with. But in the ISAT-2 Project Science Office, in the lead up to the launch, we collaborated with a number of people to develop higher level products. And so these are the ATLO6 would be a land ice height, so this is measuring heights and change of the ice sheets. Sea ice products, which would be the ATLO7 and 10, and then also products like land, water, vegetation elevations, inland water heights, and ocean elevations, and also gridded products that are a bit more user-friendly, less amount of data for people to track. And then kind of feeding into all those are atmospheric products as well, ATLO4 and 9, because all the data is coming through the atmosphere before it's hitting the surface there. So in a nutshell, these are the data products that we're producing, but I'll go through these a bit and show some examples just to show what it is that we're getting here with the data. So again, the basic level data product for most users would be this ATLO3, global geolocated photon. So just getting for each of those dots on some of the plots I showed earlier, one here, the latitude, time, latitude, longitude, and then a height. And what we also provide with ATLO3 are classification. Essentially, there's there can be a lot of background from the atmosphere, and so we have algorithms that classify those into high, medium, and low categories for whether those are signal or background photons. So in a nutshell, again, that's really the base level product that ISAT2 is providing, but the data volume is very, very large. So we're talking up to about 0.5 terabyte or so a day for this data globally. So it's very, very large, and not everyone wants to work with these individual photon heights to get the geophysical products. And so we partnered with various people, institutions, which are shown here on the chart, and they've developed higher level data products, so products that are specific to their areas of interest. So for example, for the ice sheets, we've partnered with Ben Smith from the University of Washington, and he's responsible for the production of land ice heights, and then also gridded products that when they're available, once we have enough data, we'll also be able to track changes in the ice sheet's heights. We partnered with Ron Kwok from JPL, who's leading the development of the sea ice products. So these include sea ice height, roughness, freeboard, things like that are needed to be able to get sea ice thickness. Over land surfaces, vegetation surfaces, we partnered with Amy Neuenschwander from Texas. And so she's producing especially our vegetation products, which are highly used by the community. For ocean products, getting ocean heights, we partnered with Jamie Morrison from the University of Washington for getting things like ocean heights. And then 2 people from here at Goddard for the atmosphere and inland water heights, Steve Palm and Mike Jasinski. So I'll go through some just data examples of each of the products just to give a flavor of what's coming out. This particular product, ATL06, it's used in a paper that's in press right now, should be out in fairly soon. But it's using the ATL06 data product, the heights of the ice sheets. And so just differencing the heights with the heights from ISAT mission, I was able to look at changes in the ice sheet of Antarctica and Greenland in extraordinary detail, and then do other processes to convert this to mass change. And so again, this is going to be an exciting new result from this publicly available ATL06 product. For sea ice, here's an example of freeboard data that's available from ATL10. ATL7 being the base level product, it's just taking that cloud of photons, converting it into a height, and then ATL10 is converting those heights, doing things like surface discrimination to get leads, and then converting that into freeboard. So here's monthly grids of freeboard, and again, a higher level product that should be released fairly soon, next few months, would be a gridded product from this data. So again, you wouldn't need to aggregate all the individual shots. You could just look at the gridded product directly. For terrestrial ecology, I mentioned Amy Neuenschwander has been developing some of our vegetation products. So here's an example over a boreal forest. And as you can see here, the ATL08 is tracking both the surface and the canopy and the canopy heights, trying to look at tree heights and get vegetation height and structure. And so again, this is a new publicly available product. In terms of atmospheric data, because the data are transiting through the atmosphere, we can also get information on things like cloud structure, aerosol structure. So ATL04 and 9, we have derived products from that. If you're interested in plots, we have a nice website set up just for people to look at data. Originally, this website was set up, Steve Palm, who's developed the products, it's helping him in his development of the products, but it's also useful for our immediate science community, our science team, as if we're looking at a specific track or something, we can immediately see, well, what was the atmosphere doing? Were there clouds? Was it cloud-free? Because this gives some indication of data quality. ATL12, so ocean science. So we're getting global ocean heights. And so this is just showing some examples. The left map showing dynamic ocean topography from ISAT-2 data. And then if you look at the individual height retrievals, you can see how we're seeing down to the scale of surface waves in the data. And then lastly, inland water. So we're also using ISAT-2. We have a product that measures the heights of lakes and reservoirs, rivers, and then transitional areas like estuaries and nearshore water bodies. And that's Mike Jasinski here at Goddard. So really, we have all these data products, and for distribution, we partnered with the National Snow and Ice Data Center, and all this data that I showed, it's all publicly available with documentation for the algorithms that were used to make the data products, and then aside from just the plots that I showed, all these data products have a lot of ancillary data that you can use to get all kinds of parameters with and plot data. NSIDC has various searching and subsetting tools as well for users to really narrow down to a specific region of interest if they want. And then they also provide us with user statistics. So I saw that was part of the reporting for this open data requirement. So yeah, NSIDC is able to provide us with this information. So about 1,600 users to date, 76 countries, and over 3 million files served from when we first started publicly producing data on May 28th until a couple weeks ago. But not everyone from the science community wants to use these pre-made products. A lot of times scientists want to tweak things themselves, either developing their own algorithm or developing their own algorithm entirely, or maybe they want to tweak some part of an existing algorithm to produce something that they think is either a better product or produces some kind of new geophysical information. So we have a few resources for that. First being a cloud computing resource. This it's called ADAPT. It's the NASA cloud environment. It's for NASA-funded investigators, but what we're trying to do is set up a cloud environment. Again, given the massive data volume from ISAT-2, so we're looking at like 0.5 terabyte a day for ATL03. If anyone wanted to work with that directly, it would be a pretty big challenge to do with, say, a desktop, or they'd have to get their own server. But by joining something like ADAPT, they have access to all that data, as well as ancillary data like NASA's Operation Icebridge data, and trying to have all that data in one place so investigators can have access to everything, run their codes as they need to, and then find out where they want to go from there. Turn it over to Tom to talk about the new slide rule project.
Yeah, thanks, Nathan. So as Nathan mentioned, the data volume is huge on ATL03. So one of the things we're just started working towards is getting the ISAT-2 data into Amazon Web Services. And then instead of downloading a fixed data product, a user can configure the data product to be whatever they want it to be. So for example, ATL06 is a 40-meter product, but maybe in some cases a 10-meter product would be better. So through an API interface, a user can request the ATL06 engine run on ATL03 data at 10 meters instead of 40 meters. And the idea being that we'll have a number of user configurable parameters in there so that people can make custom data products in a just-in-time sense using Amazon Web Services. Nathan, you want me to mention the Hack Week?
Yes.
As long as I'm going. So we had one Hack Week last year at the University of Washington that focused on the sea ice and land ice data products. And we'll have another one that'll be in June at the University of Washington. There was an advertisement out through CryoList a few weeks ago. Registration's open now if you want to apply to attend. I think registration closes first week of April, if I recall. In addition, we've been in touch with the JEDI mission, which is Goddard's vegetation-focused LiDAR on the International Space Station, about setting up a vegetation-focused, ecosystem science-focused Hack Week to combine ISAT-2 data and JEDI data. And that'll probably be October, November. I don't think we have a week yet, but later in 2020. And then that last bullet, past code examples available. If you go to the NSIDC ISAT-2 landing page, you'll see a tab that says Tools, and scrolling through there, you'll see all of the code examples from the Hack Week in 2019. User tutorials, how to get started, using Jupyter notebooks. And yeah, so that's all out there to help folks get started. But if you're interested, or you have students who are interested in a hack week, yeah, check it out. There's the link.
Okay, and then just to summarize things, you know, ISET2 is really engaged in a lot of collaborations to produce data for the public and then these value-added products. You know, it was mentioned in the lead up to the meeting about this Open Data Act, and I don't think ISET2 was necessarily working towards the Open Data Act. At least I wasn't aware of this until recently. But, you know, we did this to engage the science community more because, you know, we have mandates to make our data public. And then, again, the more that we can engage the user community in different ways, the more that people can make use of the data. And so, again, it just produces value for the mission as a whole. So that's been our strategy. So, yeah, we've really just worked on making our data available to the public, making it user-friendly for, you know, all kinds of users, people who want to start at the lowest level and really work with things like individual photon elevations and derive their own products. But then towards users who don't want to work at that level, but they're happy with the higher level geophysical products and can do interesting things from there. So that's all we had. Happy to take questions.
Great, thank you so much. So Jonathan, I'm pretty new to these calls, so interject, but I think that now is a good time to, after we get into questions, kind of think about directing things towards discussion points revolving around those performance elements and keeping some themes in mind, like the co-production method to enhance usability and access to data, information, knowledge. Now, ISET2 clearly what they're doing is in the vein of user-producer collaborations. Now, as was mentioned towards the end there, maybe incidental that it also aligns with these new laws that are coming out to enhance access to data and to the federal government holdings in particular. So I think what I'd like to do, you know, we get to questions, but try to get kind of bring it back to this concept of engaging the users in the process. So something, just a minor critique, maybe just to kind of kick off discussion is, and I see these a lot, I see many of these technical models about product development, and they're very helpful to understand the technical aspects, but I'm always left kind of wondering, where's the sophisticated model for interacting with the users? So it's very nice to hear ISET2, the ISET2 team kind of walk us through some of their partnerships and innovative ways that they're allowing access to, you know, power users and also kind of out of the box, so to say, users. But I'd love to see a model, like a real kind of rigorous thinking about, you know, ways that users, a broader public is being kind of engaged, and, you know, reflecting on what we're doing here, just making this work increasingly discoverable by researchers by sharing it through IARPIC, I think is in the vein of the great work you're doing, engaging users in the process. So I'll stop there. We'll bring in questions. Meredith, if you're on the line, I don't know how they're normally taken, but I'll hand it over to you and or Jonathan to start taking questions, but I'm going to try to bring it back to that co-production method as much as possible, as I'm sure others on the call as well, especially from the environmental intelligence team here, will be thinking in the same vein. So
yeah, can I just pile on with what Mike said? This demonstrates why the open data policy and this strategy for data at the federal level is consistent with scientific norms. I mean, independently, ISAT2 has gone off and built this engagement model, this strategy, and it even includes the kinds of collaborations that add value. So I think you check all the boxes from what this policy is saying, like inadvertently, and that demonstrates some sort of you know, consistency with scientific norms, I would argue. So it bodes well for this being adopted across the earth sciences. And more to Mike's point about sophisticated user engagement, the metric I saw from these slides was basically your Google Analytics. So the number of users, the downloads, it's an impressive number, 3 million. But do you know what those people are doing with the data? And so I don't know if it needs to be sophisticated. It can be through a forum like this, where you're working with the IARPIC sea ice team, for example, and just capturing through those interactions over the web what people are actually doing with those data. I think we need to start looking at being a little more sophisticated with that component, and especially now in the context of reporting this to Congress through this Open Data Act.
Hey, Jonathan, if I can comment on the uses. Those are the downloads from our National Snow and Ice Data Center where ISAT2 data goes out. Two complications we have with it, with getting the next level deeper as far as what are people using with it. One is personally identifiable information. There's only so much information that they're allowed to collect. And two is that we get a lot of data pulls from distributed clusters. So someone using, I don't know, a multi-threaded session to pull lots of ATL 07 or 10 data, we don't necessarily know who it is because it's going through another portal that allows them to pull multiple streams simultaneously. One aspect we do have a little more insight into the use of ISAT2 data is through our Applied Sciences program. We have part of the project called our Applied Sciences part of the project, where Sabrina Delgado-Arias has been engaging end users who would be involved in using ISAT2 data in a decision-making capacity. And the model that she followed was what we call our early adopter plan, where folks who were interested got in touch and got involved before launch so they could get familiar with data products and what information content is in there and how they might use it. And she's followed up with them through what we're calling now our Applied User Program, now that we're on orbit. So that's one means we've had of being in touch with end users and finding out how well our data is meeting their needs or not meeting their needs, and what we could change to help make it better for them.
Yeah, that sounds really great. It sounds like you're doing everything possible. There are limitations that we have. So let's open it up for questions from anybody on the call today. Awkward.
There's got to be questions.
Well,
So just,
I can keep talking.
Yeah, for everyone's awareness, this is Mike, MJ again. For everyone's awareness, there are plans for future meetings getting the perspective of the user. So those that are working on leveraging ISAT2 and other technologies in their own kind of production environment, whether it be for developing a new capability or developing decision support systems. So this is something that it'd be nice to cram it all in one, but it's one thing to get familiar with the technology, exposure, discoverability of what's being developed. That I think checks a very big box, and this is something that IARPIC forum is particularly well suited for. And then there's the other aspect, the user perspective. And I think following on to Jonathan's point there, I think a nice model would be to bring in kind of perspectives to emphasize that user perspective. So after hearing about an overview of ISAT2 development, hearing from the users what they're doing, and maybe kind of getting, in some sense, collaborating with ISAT2, getting around that the constraints with collecting user analytics. This is something I've actually been trying to do here at NGA. It's very difficult to do for the reasons that were mentioned. But there are other ways to capture those use cases. It doesn't necessarily have to be by ISAT2. That's something IARPIC can kind of step in and kind of bring those voices in to complete that and get an idea of how the technologies are being developed from the user's perspective. and then kind of IARPC keeping that thread kind of the story together, that we're both exposing you to these emerging technologies in line with the decision support tool development as outlined in the performance elements that we support, but also capturing that user perspective, which really gets more into the social sciences, which is an area that I think could use some bulking up on these in the IARPC calls that tend to be focused really on the science, which is kind of in many ways what you see more broadly in the environmental sciences. So bringing in that voice of the user perspective and thinking of ways to creatively and proactively engage those users in these conversations. So that's something I'm personally going to be advocating for and working on. Already doing that here at NGA. We have ongoing evaluation of uses of ISAT2, acknowledging that we know it already has very, very important uses that we're developing, but also unanticipated uses that really can only be, the full opportunities really opened up through interaction between the developers and the users. That's something that, fortunately, from what I'm hearing, ISAT2 and many of those evaluating technology here at NGA are keeping in mind. We don't fully know the full capabilities that can be brought to bear by this new technology. So one application we'll be hearing about soon, hopefully, if we can kind of get certain ducks in a row, is application for safety navigation. So the ability to chart in places where remote sensing is necessary to access. So that's one example of application that NGA is working on evaluating technology for. So any questions out there in that vein? Uses of ISAT2 or your thoughts on enhancing the user voice in these fora to get that picture about user-producer effective engagement and ways forward to enhance those effective engagements.
See, I have a question. This is Bill Manley at the University of Colorado Instar. And so these ISAT2 products, they're just so incredibly important, so helpful, useful. And kind of to spread the word more, do you all distribute geospatial files or services that display the, not footprint, but the extent coverage, maybe by year or total for these different products?
Yes, there's two different ways to get at that. One is through a service called Open Altimetry, which is linked through NSIDC, or you can just go directly to, I think the website's openaltimetry.org. Yeah, that'll show you those ground tracks of where, let's say, all of the ATL03 data is. But if you're interested in one of the higher level products, let's say 7 and 10, Open Altimetry will show you where those products exist, both spatially and in time. There's another service that NASA runs called Earth Data Search, and you can do the same thing there as well, where it lets you do, it shows the ground tracks on a reasonably familiar map interface where you can zoom into your favorite glacier or favorite estuary to see where and when the tracks came through that area.
So those are ground tracks, linear features depicting the collection of data along those tracks.
Yep.
And I'm even thinking about stepping farther more up the level of granularity, if you will. And so these ISAT2 products are not global, right?
That's right. They only go from 88 degrees north to 88 degrees south, and the width of each of those tracks is limited by the width of the footprint, which is right around 15 meters. So each one of those tracks has 6 15-meter wide swaths or lines across the map.
But in terms of you stacked all these swaths together, it's continuous from 88 south to 88 north?
Continuous in a latitude sense, but we're not an imaging satellite, so there's always going to be gaps between the tracks. In the mid-latitudes, we're doing a series of off-pointing to make as comprehensive a mapping of vegetation as we can. And after 2 years of operations, we should have the gap size down to about 1.5 kilometers at the equator. and then smaller gaps as you go north or south from there. But we'll almost certainly never have a wall-to-wall coverage of every square meter on Earth.
Sure, that's understandable. And but it would be helpful to have a really simple, I don't know, in the simplest form, a shapefile showing the accumulated total coverage, say, or by year or something.
Yeah, and that is something that one of our folks are working on here, is a geotiff-based metric of where we have, air quotes, good data or bad data, or no data. Our biggest data loss is due to clouds. Earth is about 50% cloudy at any given point in time, and certainly if you're taking data over the East Coast when there's a hurricane moving through, you're not going to get the ground surface. You'll get great cloud data, but may or may not be.
And the reason I bring this up is that there might be higher order discovery level value that is not detailed user search oriented, but just to show coverage, perhaps along with other platforms or broad data products.
Cool. Yeah, absolutely right. Hey, I'm going to have to step out because I have another meeting I have to be at 2, but Nathan is able to stay on a little longer.
Yeah,
thank you so much.
Thanks, everybody.
Thank you.
Thank you so much. We're at the time. Thanks for that question, Bill Manley. That checks the participant question box.
Yeah, Jonathan, and this is Molly McCammon. I have a comment and a question, and one is, the comment is, I think this is great what you're doing here, and I want to commend you both for the efforts you're making with this. I think this tracks really well with the whole idea of focusing more of our observing, modeling data efforts on making sure we're meeting user needs. So kudos to both of you for taking this on. The second question, though, would be, are there set user communities, user organizations, user workshops that you can make this more of a kind of formalize this into routine interactions, so it's not just one-offs here and there, but there's actually something more formalized? And then I guess the third comment or question would be, I know we have our team leads meeting coming up for IARPC in July, and there's also a whole new 5-year planning process going on. So have you been thinking about whether some of the performance elements need to be changed, some of the plans, or have you been thinking about that as well? And maybe that's too much to answer, but.
Yeah, I think you're bringing up good points. I think we discussed previously, it's hard to make much progress through these monthly calls. So I would like to start planning a workshop, and just proposing that idea now. I don't have any further thoughts on it. So we can follow up on that offline. And then for next month, I need to put in the plug. We're having a joint meeting with the observation team. And what we're going to do is look at, let me pull out my cheat sheet. Okay, at least this is what I think we're going to talk about, the value tree for physical atmosphere and ocean observations in the Arctic. And that process that people have used to show how observing systems and observations meet societal benefit goals. And that gets at this very same question. So hopefully meeting with the observation team next month, we can see how they've approached this question and learn something from the observing systems groups. So yeah, I guess to be continued. Mike, any last words?
Yeah, I'll just add on there that the next call, where we will have a joint call with the observing team, observing team, we're going to hear more about safe navigation applications of ISAT-2. It's kind of next step for this. We're actually have another call with ISAT-2 later on today to talk about some of that behind the scenes organization that will feed into the next joint call between data team and the observing team. So more, this conversation to be continued, and I really like your comments. Molly, thank you so much. It's going to be my personal effort, and hopefully I can get some influence some others in the effort as well. Identify specific groups that we can engage more formally, Some groups that I have in mind that I'm kind of thinking about include the Committee on the Marine Transportation System, participate in several working groups there, and also some of the hydrographic organizations that I'm involved in. And then, Jonathan, we can talk a little bit more offline, kind of brainstorm some fora that we want to try to engage in these calls. But point taken, Molly, thank you so much. You've given me some good homework.
Okay, thank you. So I think that brings the meeting to the close. Thanks for everybody for calling in, and we'll catch you later.
Thanks, everyone.
Thanks a lot.
Thank you.
Thank you.
Okay. And I'm just for everyone that's left on the line, we are using this line to continue a different discussion. So if you can go ahead and step out of the Zoom room. Thanks everyone for being here. Okay. And I'm not able to remove Renee for some reason, but it's okay. We can put her in the waiting room. Okay.
I think she's gone.
Yep.
Are we still recording?
Oh, good point.